Welcome to the Authority File, the podcast that features conversations about the life cycle of scholarly communication. I'm Bill Mickey, your host and the editorial director at Choice, a publishing division of the Association of College and Research Libraries. If I asked you to tell me what you think powers today's AI tools and LLMs, I bet your first guess would be computer science. And you'd be right, of course, but another discipline that's not typically thought of is mathematics. Math has played a huge role in the development of AI and still does. In this four-part series, generously underwritten by Springer Nature, I'm joined by two guests who will guide us through the mathematical foundations of and research connections with AI, and how the technology is intersecting with teaching, learning, and publishing. With me on the program are Elizabeth Loew, Executive Editor of Mathematics, and Christopher Tominich, Senior Editor of Mathematics, both from Springer Nature. In this first episode of our series, Chris and Elizabeth tell us why mathematics is often described as the engine under the hood of AI and guide us through the various areas of math that make up AI's framework. Okay, Elizabeth and Chris, welcome to the program.
Thank you, Bill.
Thank you for having us.
Sure. So, mathematics is often described as the quote engine under the hood of AI. From your vantage point as editors, what are the most fundamental ways mathematics makes modern AI possible?
So I really like the analogy of an engine under the hood. And I actually would take it a step further and say that the computer scientists and others who are designing AI, they know how the car works, and that's enough for them.
Right.
As long as it's performing its intended function, a working AI model or system, it speaks for itself. If something is fixed, if something needs to be fixed or improved, you just tweak the code and call it a day, and then everything's good. So mathematicians have a completely different mindset on things, and they always want to know why something works. They want to be able to use all the axioms, theorems, definitions they learn in school to really rigorously say this is how it works and this is why.
Mm-hmm.
And a lot of times this helps to add a level of abstraction to something, so you can actually build a model, describe it mathematically, and tweak it, understand it better that way. When it comes to AI, most of them are large language models. The LLMs, a lot of the things that they do have a direct component in mathematics. So just for example,
Yep.
LLMs, they have to analyze really large data sets to find patterns, and connections. They have to simplify that data in a form that's easier to use because you could have millions of data points or more to look through. They have to make guesses about what information is most relevant. And they have to be able to improve their own performance toward, the future. And so then if you look at math, analyzing data, that's statistics.
Mm-hmm.
Simplifying data, linear algebra, and harmonic analysis, you do that. Making guesses, that's probability theory. Improving performance, that's optimization theory. So I guess getting back to the original question, math is the engine because it provides the language and a framework to actually model what AI does.
Mm-hmm. Excellent. Thank you, Chris. So yeah, kind of tagging on to that, when we think of AI, we, like you said, LLMs, chatbots, image recognition tools, recommendation systems, and you mentioned the code and the algorithms that are created, um, but people often forget there's like a sophisticated mathematical framework driving all of this that you've just kind of talked about, Chris. You know, can you or Elizabeth, how does an idea move from a mathematical concept into a more applied area that that's sort of functional and from an AI perspective?
I think a good way to look at it is that math and all the other sciences have always had a very reciprocal relationship. There's many examples where you can say, oh, math influenced this area like physics and helped it, and vice versa.
Hmm.
So, scientists, computer scientists, biologists, chemists, whatever you think, they, will often look to math for tools and techniques, that they can apply to their own work. On the other hand, a lot of the work mathematicians doing, we call it, pure math. It's just very abstract. It's just, math for, the sake of doing math.
Right.
Uh, and so, so just use an example from AI. Linear algebra is very important in AI, and most of the techniques in linear algebra have been settled for decades. And it's only that since people have been looking for ways to model what AI does, that they've looked and said, "Oh, hey, linear algebra has this tool set
Hmm.
that we can use." It was never developed to have anything to do with anything outside of math, but they found a use for it. And so there is, this, the luck of finding something in math that helps, but there is also, times when, they collaborate. Scientists will come to a math colleague or to their department and say, "Hey, I've got this problem. Maybe you could help us."
Hmm.
And then with AI research, a lot of mathematicians are getting involved, and we're seeing more and more mathematicians who are going to like machine learning conferences or computer science conferences to, present their work and be like, "Hey, this might be good for you, or this might help. We want to contribute." So, it is, very, back and forth relationship, and the usual like scholarly communication, journal publications, conference presentations, is how, ideas go back and forth.
Right. Right. Excellent. So then, more specifically, I mean, I think you've mentioned some of the mathematical concepts and areas, Chris. But what are some of the more essential ones that help make AI actually function?
I mentioned linear algebra, and I think
Yeah.
you could argue that is, the most important, especially when you're working with an AI that relies on machine learning algorithms. I just, without going into the weeds, and the data sets that these models work with are enormous. You could
Hmm.
have millions of data points. If you look at those data points as, say, numerical values that, and you consider them a dimension in mathematics, you can treat the data as living, quote unquote, in this very high dimensional space. Using linear algebra, especially like the numerical techniques that were developed like 40 years ago, you can actually describe that data mathematically and reduce it to a simpler form. Harmonic analysis too, when you have a large data set, it can filter out the noise, which is, the data that's not relevant. And it can also, take this data that you have, again, in this high dimensional space, and extract a more general structure for it than, the more complicated one that it might look like, just because there's so much there. And so besides that, I mean, probability and statistics are also very important.
Hmm.
The LLMs that we have now, a lot of people might not realize, like, they're not actually giving you an absolute 100% correct answer when you ask them something. They can't think like we
Right.
can.
Right.
So, in the background, as they're going through the data to give you the answer, they're also calculating the probability of how correct this is. Is this the best answer?
Mm.
And when they find that, or the AI, that's the answer they give
Right.
you. So probability, statistics, all of that, from math is very important there.
Okay.
And then the very last thing I'll mention quickly, optimization. AI models, they have to learn and improve, and they can run optimization problems to help minimize errors, improve their own performance.
Oh, okay. That's cool. Because I was going to ask you, and this might be kind of a silly question, but where does mathematics show up in AI? Is it kind of written into the code, or is AI trained on mathematical concepts to do sort of its background work?
from my understanding, is that the math is used to formulate a theory, and then you can take that and develop algorithms that mimic what you're doing in the math, but in a way that the computer can read it.
Got it. Okay. Excellent. Um, are there other areas of mathematics that are just, maybe less well known that are starting to emerge, that you're seeing more often in AI related manuscripts and research? So maybe, you know, areas of mathematics that mathematicians are kind of just not discovering, but realizing that there's a connection there with AI related research.
Yeah, I guess I'll take that one.
Sure.
Yes. Yeah, sure. So here's really something that I learned very recently. Stacks and moduli. Bet you never heard of that before.
Nope.
So those are two items that are intertwined within the field of algebraic geometry.
Okay.
Okay. And in the context of AI, while stacks and moduli play different roles, okay, they
Hmm.
influence how researchers think about organizing and navigating enormous families of AI models. So LLMs are just one type of model. There's they're one type of family. Okay,
Hmm.
there are an enormous number of those. Chris, I don't think mentioned graph theory.
Right.
Graph theory, while not terribly obscure and certainly well known, has a role in AI's development. Many AI systems store their knowledge as graphs. Also, graph theory is embedded in the structure of neural networks. Neural networks are hugely important. They're one of the core computational engines of AI. So here they provide a way to approximate complex functions. And more importantly, they learn patterns from data and make predictions and decisions. Okay. And why is that important? Well, what Chris said, we know that LLMs are not designed to provide exact responses. So they analyze the massive amounts of data relevant to the problem or inquiry that you give it,
Right.
and they make a prediction that has a high probability of being correct. And we know they're not always right. Okay.
Exactly.
Category theory. Maybe you haven't heard of category theory. It's another language for structure. I read that it interacts with AI at a conceptual level, but I would actually need to go dig a little deeper to really understand its role. So I'm going to, cut that one short here. And lastly, what I came up with is game theory is becoming more and more useful to modern interactions between AI and the users and AI and other AI services. So tools from game theory allow us to create a framework to describe incentives, strategic interactions, adversarial behavior. And
Hmm.
this all works together toward improving the design and performance of AI.
You just heard from Elizabeth Loew, executive editor of Mathematics, and Christopher Tominich, senior editor of Mathematics, both from Springer Nature. Join us next week when we examine the intersection of AI and mathematical research, including how researchers are using AI and the impact of AI-related research on the academic publishing market. The Authority File podcast is brought to you every week by Choice and produced and edited by digital media producer Sabrina Kofer. Underwriting opportunities are directed by Melissa Carr and Ryan King. For more information about underwriting opportunities, download the Choice Media Kit at choice360.org. That's all for this week. Thanks for joining us.